I'll intro myself real quick. Patrick Stox. I am the product advisor, technical SEO, and brand ambassador at Ahrefs. As Dan said, I'm here to talk about site speed. I'll just share my screen. It's fine. I don't care about video. No one wants to see me anyway. So this should be fun. I was going to do this as live coding, but I went ahead and prepped stuff anyway so that you don't have to watch me type stuff. I will start this off by saying I wrote a pretty great guide to Pagespeed. It has pretty much everything that you need to know. This is worth a read. It kind of goes through step by step how to troubleshoot and different things that you can do to optimize. One of the things I wanted to do though is touch upon a section I didn't really expand upon too much in the article, and that is actually how to make a copy of a site and go ahead and test some of the changes so you can estimate the impact that the changes are going to have. I made a few examples. This is my fastest web page. It basically is nothing. Lesson number one, small is fast. This is it. This is all it takes to actually build a page that validates. If you want JavaScript, I think you have to do HTML also, and that's it. That should also validate and let you have JavaScript. So the less stuff you have, the better. I'm just going to use, I'm from the US, so hey, I'm going to use presidential websites right now because we're in kind of election season. So DonaldJTrump.com. First thing I wanted to do was basically make a copy. So I came in here, I copied all this. There were a couple things I had to change. So some of the references were relative. Obviously, I don't have those files on my server, so I'm just calling them from his server instead. So basically, some of the files were, calling assets like that instead of with the website. So I just had to fix some of those so that it would work. This is my potato box. It's like a $3, $4 a month HostGator, server. So shouldn't be any complaints that like I have a faster server or blah, blah, blah. That is absolutely not the case. And this is what I came up with. So we have a fully functioning, working site, the same as Donald Trump. All the assets, they're there. And we have some performance metrics. I want to show you one problem that I ran into. So they had this little pop-up here on his site. What I found was causing that is actually Optimizely. So I went ahead and basically just blocked Optimizely. So you see the pop-up went away. If you notice, this is a lot faster suddenly than when when Optimizely wasn't enabled. So I think I had that run. No. Well, let me run that real quick, sorry. Just to show the difference real quick. I had to rebring all this stuff back up because it all closed out on me, but I did test most stuff before. And should only take a second. Okay, so we're looking like, if you look at the metrics, performance 39, FCP 3.9, FMP 3.9, compared to just disabling Optimizely, we cut off, second and a half, a bunch in the performance, etc. So that's taking a lot of time to process that JavaScript and the things that it adds to the page. Again, smaller, faster, etc. But this gives me a pretty good baseline to say, like, here's a performance score of 70 on his site, FCP 2.5, 2.5. My version of that, 2.4, 2.4, performance 65, roughly the same numbers for everything. It's not exact, but I just recreated a site in a matter of a couple minutes to show this as an example, but all the numbers are practically the same. And what this lets me do is now I can work on this site and kind of estimate the impact of changes. So rather than like working on DonaldJTrump.com because I don't have access, I don't want to work on that site, I can just quickly do a few optimizations and see how much impact it's going to have approximately on the live server. I already know, number one, I should probably look at what's going on with Optimizely, because something there is terrible. I don't, the pop-up and God knows what else is running. So I think the first thing that I wanted to do was just optimize images, because if you look back, so this is my baseline, it's going to tell you like some things you should do, and SEOs always want to start with images. So like serving images in next-gen formats and encoding images correctly, saving that space. So I went ahead and converted all of them to WebP and encoded them and blah, blah, blah. But what I wanted to show is that, well, you can see here, like they're all WebP. I changed all these, I remade the images. It did have some impact. Like I got a little bit faster, a little more performance. It definitely increased my speed index, so sort of a win, but not as big of an impact as I think a lot of people expect when doing that. And I just used like, I'm trying to remember, I think I used Squoosh. Oops. Squoosh app. So you can like drag and drop your images and just select how you want it installed or how you want it converted. So I just chose WebP. So quick online tool just as a test, but typically you want to automate image optimization if you can. So like next up, defer all screen images. This is lazy loading. So again, like everyone starts with images. So let's see what happens. We got a couple here that show that there were a problem. What I did was I added a JavaScript library called lazy sizes, and I changed how the images were called a little bit so this would work, but that's not super important. All this is going to do is delay the images that aren't shown on the main screen. So they're not going to start loading right away. They're going to like wait and then start loading later when the images are starting to come into view. So with lazy loading, I can't say that much of anything really changed. You know, we're still seeing FCP, FMP about 2.1 seconds. Speed index may be a hair faster in this case, but nothing else. So what I'm working on right now, just to back this up a little bit, is kind of visual load metrics. So FCP, FMP, speed index. Now you have like cumulative layout shift, largest contentful paint. They're all kind of metrics that impact the visual load, like how people will perceive the initial load of the website. The reason we're not seeing any impact to like time to interactive or first CPU idle, max potential first input delay, pretty much all these are impacted by JavaScript. So when I disabled Optimizely, for instance, I did see an impact here because Optimizely is running JavaScript, it's replacing stuff. That code has to be processed. It has all the changes have to be written to the DOM. So that stuff takes time. So we'll get to that in a minute. But again, visual load metrics are kind of these initial ones just to show like basically how long this very first paint takes to show. So I wanted to show something for render blocking resources, but there weren't any on Donald Trump's website. So I came to Joe Biden's real quick. Here, you do have a few like JavaScript files that are blocking, at least one that's blocking. So most of this is taken care of too. But render blocking resources are things that are preventing the initial paint from showing. So you need these files basically, or they're blocking the things that need to load faster. Again, we're just trying to get stuff to the paint faster. There wasn't any JavaScript file, so I wanted to show one with JavaScript. Basically, all that has to be done is that this is how it would have been. With JavaScript, typically the easiest way is defer it unless it's needed for something to load above the fold, but it's not in this case. So in the code, all I'd have to do is like defer, or you can use async. Async lets it load kind of at the same time as other things, and defer just says like wait for other stuff and then load With CSS, it gets a little more tricky. I actually wanted to show this. This is my site, but I set this up real quick. So I added some stuff here to basically async load or defer the CSS. So it's going to load the CSS in the background and then apply. This typically isn't the best idea. The reason for that is what you get is what you just saw. This cumulative layout shift, basically a lot of stuff is applying after the page is loading. So it's loading, it applies the stuff, and everything just shifted and everything was a mess there for a second. It looks weird, it looks bad. I'm glad that if you haven't heard Core Web Vitals, they added cumulative layout shift as a metric. And it's for reasons like this, is that's not a great experience to just have things load one way weird and then just magically fix everything. I couldn't really show that with Donald Trump's site, so I set that up real quick. What I can do is preload. So with the CSS files, you can set a preload directive. It's pretty simple. So we have these CSS files here that I need to call, and I just added another preload directive for this. And what this is going to do is when I connect to the website, it's going to go ahead and start downloading the files. So ideally, this should mean that I get the CSS files a little bit earlier than would happen otherwise, because these might have to wait for some things and then load. This just says when I'm making the connection, go ahead and make it and start downloading these because I'm going to need them. And you'll see not really any difference. Again, on this site, I'm going through the optimizations it's telling me to do right now. You know, this takes care of, I can't see the tabs because of Zoom. This takes care of what it was telling me here, the render blocking resources. So I've technically solved for that now. And I really didn't see any impact. So if I go tell a developer like, oh, you need to solve for that, and they might solve it and you don't see a difference. Well, now you could have known that ahead of time that at least on this particular site, I didn't see a difference from doing that. So that's why the testing like this on your own site is kind of important. It helps you see what is going to have an impact and be able to prioritize that in the development queue. And it doesn't always work that way. Like sometimes there are dependencies on other things. So you might fix 3 things and not see an impact, but you fix one more and like you get a cumulative impact from all of it. So just be aware that that kind of stuff happens. Rather than preload, another way to do this is to inline CSS. So what I did here is basically I just generated the CSS that's needed for the content above the fold. So anything that's needed to display what is here, which is probably going to be font styles and some positioning statements and that kind of thing. I just used a quick online generator and basically came up with the needed CSS for this. What this is going to do is literally put it right into the code. So now I'm loading the CSS along with the HTML. So rather than waiting for another file, it's grabbing the necessary items, the necessary elements, and putting it right in the code or putting it right in the HTML. So when it downloads, it's there. It's not going to have to restyle stuff. It's not having to wait for files. It's going to be pretty much the fastest possible way of doing this. You typically want to inline any CSS that's above the fold. And you can do this at scale. There's a bunch of different programs that will let you do it depending on, if you're in WordPress or a JavaScript framework or whatever, you can pretty much automate it for every page. And so did that make a difference? Again, not really anything. And on this site, not really any difference over preload or anything like that. This is probably an ideal state now. think we've solved pretty much every major issue as far as like the visible content load. This is pretty much as fast as it's going to get without like stripping things down. So if I want this faster, I probably need to start getting rid of you know, some more JavaScript, maybe make the images even smaller, or use less fonts, or something. Like I'd have to look, but basically you need to start stripping it down if you're not happy with these numbers at this point, because that's pretty much as optimized as it's going to get. There's this pre-connect thing, but that's mainly for some of the JavaScript files, some of the third-party scripts, so that's not really going to have an impact. So the visual metrics at this point, that's almost an ideal state, except that this is still not super ultra fast. It probably doesn't help with this giant image in the background and that kind of stuff. So what's next then? One of the things that you can try is with the font. So in this case, I just added, they have what's called font display swap. And let me go back to that for a second. So under diagnostics, this ensure text remains visible during web font load. Font display swap will basically take a default style from your system and display that until one of these other font files load, or until all of these other font files load. So what I'm trying to do is use a default system font for all of these fonts that are showing up here until these load in, and then it will literally swap them to have the styling and stuff that we want. So this is another way I tried to get the visual load slightly faster with Google Fonts, which is what this is. Sorry, it's a config file, but a lot of times you'll just see a Google Fonts link, something like this. But you can add just and display equals swap to the end of the URL, and it'll do it for you automatically. In this case, it got me, you know, roughly the same, maybe even a little slower, which is awkward and shouldn't happen, but these tests aren't 100% accurate. I could rerun the same test 5 times in a row right now and get 5 different results. It's you know, it's based on connections and everything, and stuff may load in slightly different order. So the numbers are kind of relative. If you're actually testing this, you should run it probably like 5 times in a row just to get averages for all the different tests. But that's pretty much it as far as the visual load. So what does that leave? Because now I even did fonts. Now we just have like stuff like reduced impact of third-party code. So all these different scripts that we're running: Facebook, Google Tag Manager, Analytics, Yahoo, Google CDN, etc., Google Ads. You know, all this stuff is going to be impacting more the metrics like first CPU idle, timed interactive, max potential first input delay. Like these are mostly, again, based on JavaScript. So those third-party scripts are going to be what impact this the most. With Chrome, you can block these. You saw me do it earlier with Optimizely, and we saw the impact of that. Now I've just added some more blocks. So it's pretty simple. You just block whatever you want to block. I don't know. Eventbrite. There's not actually Eventbrite, but you match to a pattern, and it'll tell you like what's blocked every time you reload the page. So request blocking can help with troubleshooting if you think that something is really impacting this, which obviously a bunch of these were. So whether it's Optimizely, Facebook, Google Tag Manager, you can block certain ones and rerun it and, you know, see how this changes. You have a test history. I don't know if you'll just caught that, but I've run this multiple times to see kind of how each script was impacting it. So if you have a bunch of third-party scripts that get data and you want to argue that, hey, something here is really bad and something's really impacting it, well, just from what I disabled there, everything got really worse. So is it Facebook maybe that's doing this and rerun it and see how basically that individual script is impacting things. It might be the vendor.js was the real bad culprit, but you can estimate the impact of each script this way. So yeah, Facebook looks like it definitely had some impact. This other one, I think it's to a better state. Let me just go back a few reports. So now, like, just because of the JavaScript, I'm now to a 97 on performance. I kind of have everything into green. The problem is if you're arguing with a dev team or a marketing team on this stuff, no one wants to lose this data. So this Facebook tracking, so I can do remarketing, whatever Google Tag Manager is loading. I don't really know what vendor.js even does in this case. It might have some data that someone doesn't want to lose. So at least this way you can assign an impact to each script and know how much it's costing you, know how much it's delaying the load, and be able to, prioritize it or go back and say, like, look, do we really need these Facebook requests here? Or can we live without that if everyone's going to get a better load experience? So those are difficult conversations, and I find that it helps to come with data to say, like, this is your actual impact times every page on your website. And one more thing I just wanted to cover real quick. In Pagespeed Insights, this runs the same as what I'm running, which is Lighthouse. Lighthouse is built right into your browser. I didn't really cover how to run that, but if you just right-click and go to Inspect, you'll have a tab for Lighthouse where you can run these reports. This is Pagespeed Insights is Lighthouse. It's just done on Google's resources on their servers with consistent settings rather than Lighthouse, which is run on your own machine. It can be impacted by things like extensions. I should be running them in private, for instance, no extensions enabled to get a more baseline result. Pagespeed Insights will kind of give you that baseline result every time. So it's probably a better way to test for the most part. You also get additional data. So what we've been seeing in Lighthouse is this lab data. And what that is it's with specific settings. So I think by default, it's like a fast 3G connection on like a mid-grade smartphone. I think a Moto G4 or G5 phone for the CPU, because all that's going to impact, like, how long does it take to process my JavaScript? Well, that really depends on your CPU. How long does it take to download stuff? That depends on your connection speed. What they add extra is this field data. This field data is basically everything taken into account. So the lab data that we've been seeing only accounts for the very first page load. So this is like a new visitor every single time. Well, the reality is if you cache things, then they don't have to load it on another page or when they revisit a site. So you'll see here in the lab data, like the FCP is 2.5 seconds, but the field data, because this is now taking into account caching, it's taking into account the user's CPUs, it's taking into account the connection speeds. All this is typically going to be faster, not always, really depends on your users, but this is kind of like the real world user data and shows the buckets where things fall in. So 43% are seeing less than 1 second. Obviously, if I look at the lab data, I'm like 2.5 seconds, that sucks. But if 43% are actually getting that in less than 1 second, that starts to look a lot better. Like, maybe I'm doing a better job caching. Maybe a lot of people just visit from their desktop on their, gigabit connections rather than their, mobile smartphones with roaming data and that kind of thing. So these are more just the real world metrics. To go back 1 sec. So our final state here, from where we started, we're at, a 97 on the performance. I don't pay too much attention to the score. I pay more attention to the metrics because this is, again, like more perceived. how you're going to do. This is basically how many of the best practices did you do. But you saw we did a bunch of them that had zero impact, or maybe even a negative impact, because I think at one point we were at like 2.1 seconds on FCP and FMP. So something I did may have even slowed it down, but my score went up. But compared to the original, which I think was here, well, this was the original with optimizedly disabled. So I got a little faster on the visual load, getting rid of the third-party JavaScript. I got a lot faster on like every one of these other metrics, and the score went up. But even on the original, this was way worse. This was just, I think, with optimizedly still on. So this is kind of what I tested and saw, and like where I got to. So if I was doing this and going back to a dev team, I would say, you know, if you do these optimizations, I think we can get down to roughly, you know, 2.2, 2.3 seconds on the FCP if you do all of these different improvements. Or like, you know, if they've set a goal and they need their time to interactive to be 5 seconds, and you can hand them a list of things that say like, this is what you have to do to actually make that goal. You know, we got it down to 2.4 seconds, and I think there's still some stuff that I didn't block here. So I think it's good to run these tests to be able to do this. I should have expanded on this in the article a bit more on how, but it's not that bad. I think probably took me an hour to set all this up and run the tests just to make sure that you know, things would go through and like that I would see improvements. I picked a random site. I had no idea how it was going to work out or anything ahead of time, but you can take this kind of data back to dev teams and say like, this is what we need to do, this is what the impact will be, and they're more likely to do that rather than sending them, you know, a screenshot from PageSpeed Insights that says make it faster, or like do these things. Like that never really goes over well. Obviously, first thing they're gonna say is, what do you mean I'm gonna save 28.5 seconds? I'm loading in like 5 seconds or whatever. Like, how does that even make sense? I don't even know. I can't even answer that. I don't understand how I'm going to save 28.5 seconds when the thing doesn't even take that long to load. So stuff like that, like they're going to question a bunch of different things, you know, with this data. The cumulative data is like, I can save 28.5 seconds with this, and 28.2 seconds with this, and 5 seconds with this. Well, where am I saving that time off of? Nowhere. Not my worst metric is 9.2 seconds. So how do I even save, you know, 60 some seconds? So the way I typically see it is SEOs will send them this report and like it makes no sense, and they're like, we can do some of that stuff, but we don't really know the impact that it's going to have until we do it, and then they put it off. It gets deprioritized. So if you can send the impact of each change and know what's likely to have an impact, it's more likely to get prioritized, more likely to get done faster, get taken serious because you've put in, you know, time and effort to test this stuff.